So that's how we have the things. Now usually when coming to table creation, only DBAs would be using the command like create table, then schema name dot table name. So when you want to create a table in any other particular user or schema, then you would be using this, or otherwise normally people will be provided with create table permission, and they can able to create the table. So we don't require to specify schema name always. And this is how you are going to reference to the other user tables. So here you can see in the example you have user A and user B. Suppose user A wants to retrieve the data from user B, then the select query should be written something like what you can see here. Select star from user B dot employees. Same way user B wants to retrieve the data from user A, then it need to say select star from user A dot employees. And default option. So there is an option called default. Whenever you create the table, if you go for this default option, then the automatically Oracle will take some default values. So you can see here what this default can do. So the first point says specify a default value for a column during an insert, and literal values, expressions or SQL functions are legal values. Another column's names or the pseudo column are illegal values, and the default data type must match with the column data type. So for example, here you can see there was a table by the name hire underscore dates, and we have two columns over there. One is ID with a number of 8, and the second one is hire date, which is a date data type, but it is default to sys date. So this is one thing what we can understood from that. So whoever joins the organization, their hire date would be sys date. That means on that particular day, suppose today somebody joined in, then the joining date or the hire date will be today's date only. So like that you can specify the default option. And once you create the table, if you want to see the contents of the table, like you want to list down how many columns are there and what are the data types for those columns, and whether the column is null or not null. So in such case you can go by this describe command. So basically describe command is used to describe the table, and where you can see the column names and then the data types and their values. And this we already discussed, like about how many data types are there in Oracle and what is their advantage and all. And we don't use this timestamp things and all, so that's fine. So then constraints, so we have already gone through that. So not null, then unique, foreign key, primary key, and then check constraint. So we have these 5 types of constraints.
This is Junaid.
Yeah, Junaid.
Yeah, what is a pseudo column?
Yeah, I just read your question. So pseudo column is something like which is not visible to the to us, basically to the reader of the or whoever is inserting the data and all. It will not be visible. For example, row ID. So every row will have a specific ID declared, and there is a format for that. We will be discussing that in DBA class. So for example, this row ID is a pseudo column. So which will not be, it will be there in every table, but when you say describe the table, like using this DESC command, when you describe the table, it won't show you in that particular list. And we can say sysdate whenever you have date, so even that is a pseudo, that is having pseudo data. Like date will store on the other day I have told you this. So date is going to store the timestamp also, but never it will expose the timestamp to the end user. So what date will do is it will store both the date as well as the time, but usually Oracle will not expose this time, so we can consider that as a pseudo data. So which is not visible, we call it as pseudo. And constraint guidelines. So you can name a constraint on your own, or if you leave that chance to Oracle, Oracle will generate one constraint name on its own. And when we can create a constraint, so you can refer to the second point. You can create a constraint either at the time of table creation or after, once the table has been created. So there are two possibilities. Suppose during table creation you are not sure which column will have which constraint and all, then you can basically decide to add that constraints at a later point of time. So that is possible. And you can also define the constraint at column level or at the table level. So in the next slide I will show you an example what is the difference between specifying a constraint at a column level or at a table level. And of course we can view the constraint information from some data dictionary tables, so we will discuss about that later. So this is the syntax what we are going to follow for constraint. Now I will directly jump into the example. So this slide shows you the difference between specifying a constraint at column level and specifying the constraint at table level. So basically in column level constraint what you are doing is you are writing create table name, then opening a bracket, you are writing the column name and then declaring the data type and its value, and immediately after this column you are declaring that you are declaring a constraint or you are defining a constraint, and you are giving the constraint name over there and you are saying primary key. So when you look at this particular example, which I have highlighted, so here what happened is immediately for employee ID we have been declaring a constraint, and we are giving some constraint name. So here emp underscore emp id underscore pk is nothing but the constraint name. So and we are saying it is a primary key. So basically after writing the column name immediately you are giving the constraint. So this is one type of defining the constraint, and another one is table level. Now what happens in table level is you will be writing the create table syntax and you will be defining all the columns that you want in that particular table, like employee ID, first name, etc., etc. So you will be writing down all the columns, their data types and the values, and at the end of the table you will be declaring the constraint. So like what you can see in the second example on the slide. So these are the two ways on how to define a constraint. And if you don't do even at column level, or if you don't declare at table level also, constraint will not be created, but still Oracle will give the chance that you can go and add the constraint at a later point of time. So we don't require to worry about that. You can add the constraint at a later point of time whenever we feel it is right. So any queries over here?
Yeah. So all the constraints which can be defined at column level can be defined at table level.
Yes, all the constraints. Even it can be a primary key or and check constraint and all. But only for one constraint you need to go along with the column, or I can say which cannot be declared at table level. That is not null constraint. So whenever you want a column to be declared as not null, you need to write down that immediately after the column. You cannot declare that at at the end of the table. So except for not null, rest of all the constraints you can write down either at column level or at table level. So did that clarify? Okay. So not null constraint, we already know about it. It is going to ensure that null values are not permitted to be inserted, or not permitted, or it is not allowed to insert into the column. So when we declare any column as not null, that means those null values are not allowed. And then unique constraint, we know that any column which doesn't have repeated values, then we say all the column or the values inside that column is unique, and we can declare that as a unique constraint. So for example, email ID. So email ID can be declared as that thing. Now can yesterday we have seen one example for student management, and where we have recorded the father email ID and mother email ID. We have taken those columns. Now can you people tell whether I can declare father email ID or mother email ID as unique constraints? So we have declared yesterday two columns, father email ID and mother email ID. So what is your assumption? Can we declare those columns as unique constraints, or we should not? If we should not, what is the thing? Of course, it is not mandatory, but what I am, trying to say is, if you are the DBA, what you will do? Will you make it as unique constraint or not? Okay. So we got two different answers. So someone said, we will not declare the email ID as a unique constraint, and some other said we will consider that as a unique constraint. So what could be the right answer? Definitely, we should not declare that as unique constraint. So now you may ask me a question, why we should not declare that as a unique constraint? Because this particular email ID will be unique, and why should not we declare that as a unique constraint? The reason is, for example, there are two children who belongs to the same father and mother, and both the children are studying the same class or different classes, but they are studying in the same school. Then what happens? For both of them, the email ID, the father email ID or the mother email ID will get repeated. In such case, can we declare that as unique? Definitely no. Why? Because that value is getting repeated and it is violating the rule of unique constraint. Unique constraint says the one value should not equals to another value. But in our case, when you have two children belongs to the same family, then it will not be possible to declare that column as unique. So everybody got the point what I am trying to say? Okay, so when you have employees table, so in employees table definitely I can make email ID as unique. Why? Because one email ID of an employee will not be having another thing, so we can go for unique constraint over here. And then we have primary key. So we already know it. Primary key is nothing but a unique key plus not null. So that means null values are not allowed inside the columns. And then we have foreign key. So foreign key constraint will always refers to the primary key of some other table. And what is the necessity of making a foreign constraint or foreign key constraint to always refer to primary key? So anybody can answer this. What is the necessity in doing that? Why we should make a foreign key always referencing to a primary key of another table? Right, exactly. So it is to maintain the referential integrity or to maintain the relationship between two tables. And this is once again declared by EF code. So because EF code says we need to have the tables related to each other, and how we can relate is using this foreign key primary key relationship. And Pallavi, as you said, it is for relationship. Definitely, I will agree that. But it is the second statement which says if one table gets updated, the other also will get modified. Do you think this will be true in all the situations or only for some specific situations? Yes, so that is what I am trying to say, because all the time it won't happen that when you update the primary key table, then automatically the second table also will get updated. For example, if I am changing the employee name in the employees table, it won't have any impact on the departments table. Department table will remain as it is. Only if I am changing something to the department number or something in the employees table, then it will have a direct impact on the foreign key table. So this is how we are going to declare the foreign key constraint. So we need to specify the foreign key name and then the keyword as foreign key, and in bracket we need to specify on which column we want to create foreign key, and which is this foreign key to which primary key it is referring to, and of course the table name and the column name we need to define that. Now a question for you. Suppose I have a employees table. In that table I have a column called department underscore number. So listen to this question carefully. I have a table by the name employees, and in the table I have a column by the name department underscore number. Now I have another table by the name departments, in which I have a column called department underscore ID. So that means the column names between the employees table and the department table are not same. So in employees table you have EMP underscore number, DEPT underscore number, and in departments table you have DEPT underscore ID. Now is this first of all possible? So that means, is it possible to have different names in of a column between the parent and the child relationship, or do we need to follow the same name across all the tables? So what is your opinion? Yes, so you people are exactly right. So it is possible. We don't require to have same column name. Column name can be different, but ultimately what it is referring to is important. And there are some few things that we need to remember when we have in foreign key constraint. So as we already discussed, foreign key is going to define the column in the child table at the table constraint level, and the foreign key is always referencing to the primary table or the parent table, we call it as. And we have an option called on delete cascade. So while creating the foreign key, you can declare that foreign key as on delete cascade. Now when you declare that as on delete cascade, what happens? You can read the description. It will delete the dependent rows in the child table when a row in the parent table is deleted. Suppose you deleted one row. So when you declare a foreign key with on delete cascade, what happens is, if you remove a row, if you delete a row in the primary, then automatically the corresponding row will be removed from the the second table or the referencing table. So this is what earlier Pallavi is referring to, that if one table gets updated, then automatically the other table also will get updated. So how that is possible? With the help of this option on delete cascade. And then we have some other option on delete set null. Suppose you want something like, if one table got updated, you don't want another table to get updated automatically. In that case, you can use on delete set null. In which case, what happens is, when you delete some data from the primary key, then on the secondary nothing is going to happen, and it is just going to make the foreign key values as null. So that is how it is going to work. And check constraint, so we have been discussing about it. One example which was given here is checking the salary, something like check salary greater than 0. So what happens when you are doing insertion? So if you by mistakenly enter a salary as 0, then Oracle will do this check constraint, and it will verify whether the value that you entered and the condition what you have specified are matching or not, and according to that it is going to change or it is going to throw an error. So we have a very big syntactical example. So this is one more thing that you are violating the constraints. So whenever you want to update the foreign key, then it should have a proper primary key configured. So if we don't have that, we would be landing up with this particular error. And the other thing, so you cannot delete a row that contains a primary key and that is used as a foreign key in another table. So this is one more restriction we have. And here you can see the delete command was written very simply, like delete from departments, where the department ID is equals to 60. So here what happened is, you tried to delete a foreign key, you tried to delete a primary key, but a foreign key was already there which is referencing. So that is the reason you would be landing up with that error, integrity constraint violated and the child record form. So then we have an option to create one table from another table. So if I have already some table existing, I can go and create another table from it by just writing a subquery for the first table. So how that is possible is something like this. So here what basically we are doing is, we are going to create a table with the name DEPTIET, and we are writing down the select query over there. So something like select so many columns from employees where department ID equals to 80. So we can have something like that. And then we have alter table command in DDL. So till now whatever we saw is create table. So now we have alter table command. So what are all the possible things for this alter table? You can go and add a new column, and you can modify any existing column, or you can define the default value for the column, or you can even go and drop a column. So these are the different options that we have with columns or with the alter command. And finally, how we are going to drop the table using very simple syntax: drop table, table name. Now what happens when you drop a table? As you can read on the points there, all the data as well as the indexes will be dropped, and any pending transactions are committed. So if you want to drop a table and at the same time some operation is going on, some update, delete, etc. are going on, then what happens is those transactions will get committed well before you drop the table. Now here you people need to ask me one question, or I would rather ask you guys a question. Anyway we are dropping the table, then what is the necessity for having those transactions committed? Means why do Oracle need to care that those transactions should get committed? It can just simply drop the table, right? So do you guys got my question first of all? So what I am saying is, any when you do some update, delete or insert on a table, and on the other window when you are dropping the table, what Oracle will do is it will wait for these transactions to get committed, then only it will allow to drop the table from another window. So my question here is, anyway you are going to drop the table, then what is the necessity of having those transactions committed? Okay, so Pallavi, you said update the data in the database and have permanent changes. But when you drop the table, those permanent changes also will go away, right? Then what is the use of those permanent changes? That is my question. Sanjay said if I drop the table, all the transactions are going to be dropped without backup. Or Sanjay, I couldn't get your point. And Junaid, we don't have an option for rollback in DDL statements. Okay, if I drop it, any backups needed? Okay, you mean to say for backup purpose it is going to get committed? Do you mean to say that? Okay, but Oracle will not take any backup internally. So in that case, we don't really bother about it. Okay, so to avoid the things, to avoid more confusion, basically here what Oracle is following is, a way how it is going to work. So I may not clearly explain the things here, because if I want to exactly make you understand about this, I need to explain Oracle architecture, but which is not the right time now. But as of now, you can just take the answer as for read consistency, or for database consistency, I mean to say. So why the transactions will get committed even though the table is getting dropped is, it is just to maintain the database consistency. And how that will be achieved, you will understand when we are dealing with Oracle architecture. And yes, the indexes, corresponding indexes what you have created on the table will also get dropped. Then the constraints, and last and final point, you cannot roll back the drop table statement. So once, not only drop table statement, either it is a truncate table or create table, alter table, once you have given it, that's permanent. So all the DDL statements are auto commit by themselves. So this is what we say in general. So that is what we have. We will be discussing this point in DBA more clearly, but I would like to tell you one point here. When we have a 10G database, so Oracle 10G version got introduced a new concept called recycle bin. So just like our Windows operating system will be having a recycle bin option, even our Oracle database also will have recycle bin option. Now what is the purpose of this recycle bin option is, whenever you drop a table, either mistakenly or wantedly, the table will not get deleted, but rather it will go and sit in recycle bin. So just like how it works in Windows operating system, if you delete a file, how it goes to recycle bin and it will store there. So same way, when you drop the table, the table will not get removed from the database, but rather it will go and sit in recycle bin. So the advantage is, whenever you want to get the table back to the original place, you can do that using a simple command. So that is the advantage we have with recycle bin, and more about recycle bin we will be discussing during Oracle DBA course. So those are the things that we have with DDLs. Then we have the other database objects, starting with a view. So now what is a view? So as you can see in the diagram over here, view, the general definition we say is, view is a logical representation of a table. Now what that means, as you can see in the diagram, out of entire employees table, if you want only 3 rows to be visible to a particular user, then you can actually create a view. So that is what you can do. And now with this, we are going to achieve two things. One is, you can restrict the access for the data to a specific set of data, and one more thing is the security. So where these views and all will be helpful. For example, if you log into internet banking, you can able to see the details of your own account details, but you cannot be able to see other details or other bank customer details. So how that is possible? Because of the concept like view, where we can provide the access to only a particular row or particular set of rows. So these are the advantages of views. So basically we use views to restrict the data access or to make the complex queries easy, and to present different views of same data. So that is what I am trying to say. Different views of same data means, from the same table you are going to give the data to different persons using different views, and to provide the data independence. So like a view will also act as a table, and people really, the end user will not be able to know whether that is a view or a table. So Oracle is going to maintain that kind of transparency here. And there are basically two types of views. One we call it as simple view and other one we call it as complex views. Now in simple view, how many number of tables are involved is only one, whereas in complex view there will be more than one table. And we cannot have functions in simple views, whereas we can have functions in complex views. We cannot use any group functions in simple views, which we'll be discussing later, like average or minimum, maximum. All these are group functions which we cannot use in simple views, but we can use them with complex views. And DML operations through a view are also possible with the simple views, but not always it would be possible with a complex view. And this is how you are going to create a view. You would be writing create view name, then you will say as select whatever the columns and then the table name and the where condition. So this is the very simple syntax that you would be following. And as I said, the view will also act like a table. Just like how you describe the table, you can describe a view also. And you have an option for modifying a view also. In case if your select query options have changed, then you can use an option like create or replace view. So what this command will do is, if at all view is not there, it will create the view, but if at all view is there, it is going to replace the existing view. So you can do that. And here we have an example on how to create a complex view. So as I said, complex view is something like two or more than one table will be involved and some join conditions etc. would be there. So usually depends on the business requirement, we will be creating the complex view. And these are the rules for performing the DML operations. So you can usually perform DML operations on simple views, but if you want to perform a DML operation on a complex view, the following four things are that we need to keep in mind. Like you cannot remove a row if the view contains a group function or it contains any group by clause or the distinct keyword or any pseudo column like row number or the row ID etc. So the same thing is getting repeated in other slides. So now you can create something called read-only views also. Now when you create read-only views, what will happen is strictly DML operations are not allowed on those views. So something like this. So here what you are doing is you are creating a view as select some column names from the table names, and then you are saying with read-only option. So what happens when you give this read-only option? You cannot modify or you cannot insert the data or you cannot update the data. So all the DML operations are not possible when you declare that with a read-only option. And how you are going to drop a view? The command would be simple, drop view and then the view name. So this is what basically we have with views. So any queries over here? Yes, Pallavi, I would be providing all these slides to you, so there is no issues with that. Okay, so hope we have cleared on that part. Then we have sequence numbers. So basically a sequence, the name English word itself is going to tell you that a sequence is nothing but something like a continuous generation or continuous number generation, or which is a continuous process. So you can refer to the points in sequence over here. A sequence is a automated process to generate the unique numbers, and a sequence is a shareable object. That means you can create one sequence and you can use that in multiple tables. Usually we do use that for serial numbers, and when we want to declare that serial number as primary key value, etc. The advantage in using the sequence is, usually if you don't have sequence, you need to write a small PLSQL procedure, or a small function or something, so that you can generate one sequence number every time. But the advantage now is, with the help of this sequence, you can avoid that code writing, and it will speed up the efficiency of accessing the values, because these values can be stored in memory portion. So we have that option with us, and this is the basic syntax on how to create a sequence. So first we would be providing the create sequence name. Then we would be specifying increment by how many numbers, and at what number it should start, and what is the maximum value and what is the minimum value, and do you want to go for cycle or no cycle. So I will talk about what is that and all, and cache or no cache. So for example, if you look at an example here, there was a sequence that is getting created, and the options are given like increment by 10 and start with 120. That means the first sequence number will be 120, and the next sequence number will be 120 plus increment by 10. So that is 120 plus 10, which is equals to 130. And the third sequence number will be 140, then 150, then 160. So it will keep on increasing like that. And what is the maximum value that it can reach is 9999. But when you keep on giving this increment of 10, the last possible value is only 9990. You cannot go more than that. And no cache, that means you don't want to remember these values in the memory. And no cycle, that means suppose once the max value is reached, like you got 9910, then if you specify cycle, then what happens is after 9910 it will start with 9990, it will start with again 120 and 130, etc., etc. So that is the main thing over there. So cache means it is going to store in the memory, and the cycle means it is going to start again from the scratch. And if you want to retrieve the current values or the next value, these will be stored as a pseudo column in the sequence. So you need to write some select query like this. So as you can see below portion of the slide, you have a select statement which says select the sequence name dot curval from UL. So what happens with this is that particular sequence current value will be known from this particular table. So the caching the sequence in memory gives faster access to those values. So what is the requirement to store our sequence values in the memory? So it is just to improve the performance of the database, and when we will get gaps in the sequence means when it happens that the earlier sequence number is 120 and the next sequence number is 150. So usually it should go by 120, 130, 140 and 150. But let's assume I have one number with 120 and the next number has some other number. So why that gap will occur? It's basically because of these three reasons. Like a rollback is occurred on the table, or the system has crashed in between, or a sequence is being used by some other table also. So these are the few reasons why we need to have a gap. And anytime you can go and modify the sequence, you can increase the increment value, or you can go and increase the max value, or you can change the cache mode or the cycle mode. And these are the guidelines when you want to modify a sequence. So first of all, you should be the owner, or you should have at least alter privilege for the sequence. And when you change something, the existing sequence numbers will not get impacted, only it is applicable to the next versions. And the sequence must be dropped or recreated to RAS the sequence reached at a different number. So if you want to again start the sequence from a different starting point, then either you need to drop and recreate the sequence. That's the only option that we have. And some a kind of validation will be performed. And if you want to remove the sequence, of course you would be using drop command. So which says drop sequence, then sequence name. So basically in real time, this will be used for most of the times primary key generation. So, and again it depends on the business requirement and all. So are there any queries? Okay, so that is how we have the things. So tomorrow we will continue with the rest of two other objects like the indexes and the synonyms, and also we will be looking into the practical things on how to create a table and how to create the indexes, all those things. So thank you everyone for joining the session, and tomorrow also it would be the same link. So please use the same link and join at 8:30. So and tomorrow I would be sending out these things like the PPT which I am showing you, and also some SQL material is there with me. I will be sharing that thing also.